Hello, and welcome to my poster presentation of my senior capstone design thesis project, Design of an Omnidirectional Light Bar. My name is Levi Howell, and my background is as a mechanical and manufacturing engineering student here at MSU. I've had previous experience in the field of design as an undergraduate research fellow here at MSU, doing design work, rapid prototyping, and writing technical papers. This research project aims to add to the field of industrial design by designing a product that not only applies the aspects of Six Sigma, but promotes customer safety in recreational activities. This project, the design of the omnidirectional light bar, seeks to produce a product that can be mounted on an individual's vehicle and assist with illumination when partaking in recreational activities such as overlanding and off-roading. This design will assist with the driving safety and allow for the additional use for when the vehicle is idle. Finally, this project seeks to determine the cost of not only construction but environmental impact. The solution approach used for this project consisted of a five-part approach that employed engineering technology fundamentals of design. The first step, research, consisted of seeing what designs existed and what materials were already used. The second and third step involved concept and CAD design, which determined requirements and created a extensive 3D design. Finally, in the fourth and fifth part were stress analysis and cost analysis. They were performed to determine the efficacy of the design. 2 weeks were allotted to research, to gather sources on materials, lighting methods, and driving habits. 2 weeks were devoted to concept design, determining all the requirements to make a competitive product. 4 weeks were dedicated to CAD design, to create an extensive 3D design. 1 week was dedicated to using the same CAD program to evaluate the stress and perform failure analysis on the design. 1 week was also used using the same CAD program to determine costs associated with manufacturing and sustainability. The first top left figure is the final render of the omnidirectional light bar. It is a 4-rail system with an existing light bar attached to it. The aluminum rails allow for rollers to swing the light bar around within the system. These rollers also act as stoppers to lock in the light bar to place to the desired position. Pictured in the top right-hand corner is the lifter, spring, bolt, and roller assembly without the aluminum rails. There's also the aluminum rails and the T-slot nuts, which incorporate another part of the design, the fact that it uses as many standard parts as possible. In the bottom left-hand corner, there is the stress analysis of the von Mises stresses on the lifter, which shows that there was some deformation, meaning that the project could be strengthened by making it out of steel instead of aluminum. And finally, in the bottom right-hand corner is pie charts that explain the percentages of different parts of the environmental impact. From the results that were gathered from the stress and cost analysis, it was determined that for added strength, the production materials would need to be changed to steel instead of the aluminum alloy used. However, design could prove to be cost-effective, being designed to be easily manufactured and assembled easily, as well as use the maximum amount of standard parts possible. The final design remains competitive, cost-wise, and meets all criteria set forth. Thank you, and have a good evening.